You have all this thing, right? So no need trying to please them. You have the outline, right? I sent you the outline, not today. Are you serious? Wow. Who has it here? Who has it? Who has it? Who has it? Ask. Who has it?
Nobody. Someone has it.
Maybe someone has it. She has it. I know she will have it. Okay. Now, I don't want to waste time. Please sit here. After I go back to your WhatsApp, you can repost it. Are you there? You can repost it so that if you post it, please, you can even download it, print it out. You can download this size of it, please. Don't forget to cover. No, that. You can download it, copy it. The first page. Let me give you an idea. The first page of your notebook. The first two pages of your notebook. You can copy it. Take time. If you can print it out, copy it out. Organize it there. It will help you a lot. So organize it. Just write it out there. Let it be the first thing that will appear in the first and second page of your notebook. It will help you a lot. Then, and I want to advise you, if a lecturer gives you a handout or a course material, please learn how to make notes from those course materials. Let it be in your notes. Then let everything be in one word. It helps a lot. Both the lecture in class and the one you put everything side by side. Compare the two of them. It will help you a lot. Even while writing your examination, preparing for examination. But if you scatter your material, that's how you scatter. That's how you will be disorganized. You are taught to be scattered because people think that you will be confused. But if you start from the day one organizing your materials, and if you just get the important information there, align it in your notes, it will help you a lot. It will help you a lot. That's one mistake most people make. Now, first of all, as introduction, as we have introduction, the course we are talking about is what? Pharmaceutical calculation. As you can see, is applied. It's an applied course. It's applied because the concept of chemistry is there, mathematics is there, physics is also there. Chemistry is there, mathematics is there, physics is also, even some aspect of biology is also there. So by the time we start treating some topics, you will understand why I say that chemistry, physics, mathematics, and biology. So please, the course is what? Pharmaceutical calculation. So what is pharmaceutical calculation? What is pharmaceutical calculation? If you hear pharmaceutical calculation, don't be afraid. Don't think it's one big calculation that you will not be able to solve it. It's not true. I think it's time I silence this one. Let me focus. Now, what is pharmaceutical calculation? Pharmaceutical calculation is an area of study that deals with application. It's an area of study that deals with application. It's an area of study that deals with application of basic mathematical principles. It's an area of study that deals with what? Application of basic mathematical principles. in the compounding, formulation, and dispensing of drugs and other pharmaceuticals is an area of study that deals with the application of basic mathematical principles in the compounding, formulation, and dispensing of drugs and other pharmaceuticals. The definition is self-explanatory. Basic mathematical principles. So, of course, you know the basic operations in mathematics. In FAMCA, what at this your level, as a pharmacy technician, as a pharmacist, working in hospital, community pharmacy, the basic mathematical operations you need to be able to dispense, formulate, or compound medicine is the four basic mathematical operations, which are what? What are they? Addition, subtraction, and what?
Multiplication.
That's what you need. But the problem now is this: how many people? This is what basic operations in mathematics. This is what you need. But the point is this: how many people actually know how to use this? You'll be hearing this from their first year, from what might say, nursery school. But how many people can actually make use of this? Know the rules behind this? That's where the problem lies. There are a lot of things behind it, not just addition. But the point is that in the course of this pharmaceutical calculation, anytime you notice that if I deviate from any of this and introduce something else in this course that is not boiled down to addition, subtraction, division, and multiplication, then, in fact, you can do anything to me. Anything of your choice, I will accept it. The point I'm trying to make is this. This is what you need to be able to comfortably work as a pharmacy technician or a pharmacist in hospital, community pharmacy, dispense, compound, and formulate medicines. Now, of course, as pharmaceutical calculations, as a pharmacist of pharmacy technician, working in pharmacy, you need what? Pharmaceutical what? Pharmaceutical what? Calculation. By in the definition, you don't ask again what is the application of pharmaceutical calculation. It's true of us. You need it in what? Compounding. You need formulation of medicine and other one. Now, but I didn't say, listen carefully, I didn't say that this is the only thing you need in pharmaceutical calculation. Pharmaceutical calculation goes beyond just working in pharmacy or hospital dispensing drugs. No. But I say at this your level, at level of hospital, working, interacting with patients, this is just what you need. But beyond that, there are other areas you need something more than this. That's maybe for those that in academics, those that if you go maybe towards research, clinical trials, drug developments, drug discovery, research, pharmacoeconomy, pharmacokinetics, other things that that is beyond just seeing patient, because you cannot come to a patient and start telling the patient the pharmacokinetic profile of this drug it has a steady big maximum concentration. What is this saying? What the patient want to hear is take this one 2 times a day for 5 days. That's what you want to hear. But what happened in the background before you arrived at how to take it is not his business. That one is even beyond your scope. There are a lot of work to that. This paracetamol you see, they say you take it 3 times a day. There are a lot of things behind it, not just take it 3 times. A lot of researches, that's why I say that in those ones now you need something extra, not just addition, subtraction. You know that you even need both integration, differentiation, all those things you need. But for you to interact with the patient and hand in a drug to the patient, you don't need all those ones. All you need is basic ones. Are you with me? Now, these basic mathematical principles will now lead us to the first topic we are going to consider in this course. We want to talk about numbers and what? Numerals. Numbers and what?
Yes.
Because it has to do with numbers. If you don't understand what numbers, in reality what numbers is, the term numbers, you may not understand. You may have issues understanding the course. Because some of you ask now, what are numbers? Who can answer? What is a number? From notice to right, you hear number. What's a number? Who can define the term number for me? Who can define the term number for me? Number is a digit. Who else can define number for the term number? Who? Types of numbers. Have you seen it? We'll be writing one number up and down, making it up and down. But who will tell me what number? What is a number? Okay, we'll talk about numbers so that I will have an overview of what numbers are. So that we now talk about numerals. So that we now move on to other topics we have. Now, what is a number? A number is an abstract idea. Of course, an idea is always abstract. So we can simply say idea. Are you with me? No, an idea is always what abstract. Can you touch an idea? So it's abstract. So you don't say, I wanted to say abstract idea. Just write idea. It's okay. A number is an idea conceived in the mind.
Incoming year. Who? This class.
Yes.
Who is the staff?
That's it. He's not here.
No.
Okay.
What was the last year?
He's not here. Hello. Now, a number is an idea conceived in the mind on how to count or measure a quantity. A number is an idea conceived in the mind on how to count or measure a quantity. So that idea which is abstract, you conceive in your mind, is a number. Any idea you conceive in your mind that is geared towards helping you to be able to count 1, 2, 3, 4, or measure is a number. Now, numbers and numerals. No, let me talk about numerals. I'll still go to numerals. Let me just finish with numbers. I'll talk about numerals and tell you the relationship between two of them. People think that they are the same thing, but they're not what? The same thing. Now, we have two main categories of numbers. We have the real numbers and the imaginary numbers. Real numbers and imaginary numbers. Real numbers, imaginary numbers. Real numbers, I'm coming. Numbers, real numbers, imaginary numbers. Real and what? Imaginary. Our focus here is in what? Real numbers. Those in engineering, other aspects of science, we do more on imaginary numbers. But our concern is under what? Real numbers. Now, under real numbers, we have discrete numbers and continuous numbers. Discrete and what? Continuous. Discrete and what? Continuous. Discrete numbers are those numbers that are distinct. They are distinct. Distinct. Distinguished. They exist as different entities on their own. And they are distinct. They are countable. They are the counting numbers. Are you with me? Under discrete number, when we are done with this, we enter this one step by step. Under this discrete numbers, we have natural number. Natural number. We have whole numbers. Whole numbers. We have integers. Integers. Yeah? Integers. Integers. Then we have rational numbers. Rational, natural numbers, whole numbers, integers, rational numbers. Natural numbers are designated with N, whole numbers W, integers Z. Then rational numbers are this will take us to number line. I use number line to describe these numbers. Instead of number line, right? Right? So I'll use number line. A number line goes like this. A number line goes like this. It starts from negative infinity and ends in positive what? Infinity. In between them, you have the what? Zero. So the left of the zero is the negative. The right of zero is the what? Positive. So any number from infinity, you can start counting down. Minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0. Then from here again, this side is positive. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a number line. Are you with me? This is a what? Number what? Line. This number line represents real number. Real what? Numbers. All the numbers in this number line are real numbers. All the numbers in this number line are real numbers. Now let me show you. In this number line now, we have discrete numbers and continuous numbers in this number line. Discrete numbers are distinct on their own, countable. These ones you are seeing, watch out. You can count them, right? Are the what? Discrete what? Numbers. Between these 9 and 10, do you know there are millions of numbers? Are you aware? Are you aware? You don't know. Know it today. Between 9 and 10, you think you just 9 and 10. There are numbers here. Some are continuous. You can't even separate, say this is where that number stop. It continues. Are you with me? That's why I said that this line consists both what? Discrete numbers and continuous. Those who are no longer like this are the what? Those who are that are on their own like this are discrete numbers. There are also some fractions inside it that are still what? Discrete. Because rational number, when we go down there, you understand what I mean by rational number being a discrete number. Are you with me? Any question? Any question? In between these numbers we are seeing now, this space here, there are millions of numbers there. In fact, there are still one that are discrete. There are still one that are what? Continuous. That you don't know where they are ending. They can never end. They join, keep going. It's continuous. Are you with me? Are you with me? Something like pi. Don't worry. We'll get there. Let me take it step by step. Now this is the number line. Now let's use this number line to describe all these things. Okay. Now remember we are in what? Discrete numbers. There are discrete numbers. These things are discrete numbers. This one you can see are discrete numbers. There are still discrete numbers that are still between this line, and there are still continuous numbers that are still in between these discrete numbers. Are you with me? Now let's talk about natural numbers. What are natural numbers? Let's start with integers. Yes. Let's start with integers. It's better we start with what? Integers. If you look at this number line now, integers are all the discrete. Integers are all these discrete numbers you are seeing now. All these numbers from negative infinity to positive what? Infinity. They are what? Integers. Are you with me? All these discrete numbers you are seeing now, from negative infinity. You know what I mean by negative infinity? As in agua, the end of the negative side, end of the other end that is not, you can never say where it ends. That's what I mean by negative to what? Positive infinity. Are you with me? All the numbers you are seeing are the what? From the negative to the all these numbers on the number line you are seeing from here to that are what? Integers. Are you with me? Are you with me? They are what? Integers. So minus 10 is an integer. Are you with me? Minus 9 is what? An integer. These discrete numbers you can see, duly represented on this number line, you can see, are the what? Integers. From minus 10, minus 9, minus 8, minus 7, minus 6, 0 to minus 20. You can present it fully without, going, breaking down anything. That is what? Integers. And what are natural numbers? What are natural numbers? From this 0, natural numbers are numbers from 0 to positive what? Infinity. They are the what? Natural what? Numbers. Natural numbers are numbers from 0 to positive what? Infinity. So they are integers. You can define them as integers. Integers from 0 to what? Negative what? Positive what? So these numbers in negative are not what? Natural numbers. This one minus that are not natural numbers. But from 0 to the positive infinity, they are what? Natural numbers. Let's talk about whole numbers. Whole numbers. Whole numbers are simply positive integers whole numbers start from where? Are you there? Are you there? 0 is not there. It's not equal to what? Whole number. Positive integers from 1 to the positive infinity make up the what? Whole number. Please, as we are discussing, my pattern is that if you keep quiet, I will believe that you are following me until we meet the exam hall. But if I'm teaching, you cannot follow it, please ask me to don't keep quiet. Don't keep quiet. Okay? Now let's talk about rational numbers. Rational numbers. This is where fraction comes in. Are you there?
Okay.
In rational numbers, that's where fraction now comes. So rational number is this here now. Look at them where rational number can exist here. Good. Even though they are discrete, but they are still in between. That's why I said there are still discrete numbers that are in between. Are you with me? So fraction now is here now. Negative integer, positive integer, negative integer, positive integer, integer, right? Negative integer, positive integer. From here to here is what? Plus 0. To here is what? This. Natural. So natural numbers are positive integer plus 0. Zero is a neutral integer. It's not positive, it's not negative, but it's an integer. I hope you know. 0 is an integer. It's not positive, it's not negative. It's in between. You can call it neutral. But it's an integer. So we have negative integer, 0, positive integer, right? Now, from here now, 0 plus positive integer is what? From 1. Now, rational numbers exist here in between, but they are fractions. They are discrete. Now, let's talk about rational. What are rational numbers? Rational, the term ratio came from the ratio, rational. Can you see any similarity? Ratio, rational. When they say ratio, what comes to your mind? Fraction. True or false? Ratio of A to B cannot touch. A ratio B can be expressed as what? So this is a rational number. But there is something you need to note about rational numbers. So rational numbers are fractions in which the numerator and the denominator are integers. Note that point. Rational numbers, fractions, in which the numerator and the denominators are integers. That means they exist in this form. This is the what? Numerator. True or false? Numerator, right? And this is the what? Denominator. And this is what? Fractional what? Line. This is what? Fractional what? Line. If this is how you can, apart from this ratio form, you can express it as fraction like this. The numerator is there. This is fractional line, and this is the what? Denominator. Now, but one thing you need to note is that I said that rational numbers are fractions in which that exist in this form, in which the numerator and the denominators are integers. But A can be 0. If you say integer, you may relax and say since 0 is integer, that means 0 can be numerator and 0 can be denominator. It's not true. Rational numbers are integer, they are fractions in which the numerator and the denominators are what? Integer. But the numerator can be 0. The numerator can be 0. But the denominator can never be what? 0. Is 0 an integer?
Yes.
So in rational number, the numerator can be 0, but the denominator can never be what? 0. That's why if you see a fraction like this, 0 over 2, I say again. Man, if 2 over 0, I say again. Hey! I say again. Undefined. True or false? Did you do undefined in your secondary school? It's undefined. You saw, I get to this point. This is what? Undefined. So this is not a rational number. This is 1 over 2 is a rational number. 3 over 4 is what? Rational number. Are you with me now?